Welcome to the Laboratory, a video series brought to you by Miracles Innovation Labs. Hi, and welcome to the Laboratory video series brought to you by Miracles Innovation Labs. My name is Chanakya, and I'm part of the Innovation Labs team at Miracle Software Systems. Today we'll be talking a bit about serverless technologies and one of the use cases that you can use it for, which is an image processing pipeline. We'll be seeing kind of what the details of that will be through this video. So our agenda for today will be kind of introducing you to serverless technologies, what it's being used for. We'll also be talking a bit about OpenWhisk, which is an open source serverless platform. I'll be showcasing to you a quick use case around image processing and why serverless is a good platform to use for that, and we'll end it up with a quick demo as well. So as you can see, kind of a evolution of how compute has changed for IT organizations, and you can see we started off with those physical servers and kind of moved into virtualization to optimize that. And as we optimized it even more, as cost, speed became factors, we started to move these virtualized machines over to the cloud in an infrastructure as a service model. We then slowly started to move and say that virtual machines were becoming kind of too heavy. We wanted more portability, more lightweight options for these microservice-based architectures, and in came containers. We slowly then started moving on top of that, using that principle within the cloud to build these services where developers can be even more abstracted in platform as a service models, where you deploy your applications and services onto these platforms, and they manage how it gets deployed, where it gets deployed in these individual containers on the cloud. And that's where we moved into platform as a service. Today we now move into a new compute option, which is serverless, where we're talking about abstracting it even more for developers, where we're saying don't even worry about managing how many instances you want to run, or what sort of OS you want to run on, and all those things. Define what language you want to run in and build these stateless microservices on top of the platform, and it will handle making sure that it runs, making sure that it's available, making sure that it can scale, and all those sorts of things. So serverless essentially does not mean that the server is gone. You still have a server. It just means that you're abstracted from having to manage and provision the server. Other than cost and speed being basically a driving factor towards this evolution in compute, there's a lot of other things, including the overall developer experience, and also the ability to rapidly take an idea into an application has really driven us towards this new model of compute. So what is serverless? Based on Wikipedia's definition, it's also known as function as a service, and it's basically a cloud which could be kind of misleading. It could be open on-prem as well, but it's basically a computing model in which the provider basically manages everything regarding your servers and your services and your applications that are running. But more than that, it's about optimizing what is running, right? In a platform as a service model, you basically are getting all that, but in a serverless model, you're only starting and stopping your services whenever there is a need for them. So whether it's a REST-based request or a event that is triggering the start of your function, that is when your actual container or your server is being actually created and run, and then brought down once the work that it's supposed to do is completed. So essentially this saves a lot of time and cost for you when you're running your services, especially if they have to scale up rapidly at one point in time and then not at all run at another. It really ensures that you're only running what you need when you need it, rather than having to run and manage everything 24/7, 365 days in a year. So OpenWhisk is an open source serverless platform. It is part of the Apache incubator projects. It was created by IBM and is now maintained by them and Adobe as well. It's available as a managed service on Bluemix, so if you want to run it and don't worry about using it, you can do it on top of Bluemix, or you can also take this and run it on any other cloud that it supports. It does support OpenStack if you want to deploy it on-prem as well. So some of the components that are included within OpenWhisk are actions, which are basically those services that you create. You can also chain these actions together into something called sequences. You can define rules and triggers so that whenever a particular event like a message into a queue or a database change occurs, you can actually trigger these sequences and actions within OpenWhisk as well. You have a number of pre-built packages and feeds, which are basically predefined events and predefined functions that you can use. If you don't like them, you can create your own as well. There's a lot of community packages and feeds available out there as well. It also comes along with the gateway, which allows you to expose these event-driven functions as REST services also. In terms of the developer experience, there is capability for Java, Swift, Python, and Node.js as of today. But if there's some language that you do not have that is supported that you want to deploy, you can still use Docker containers. Any of your existing Docker containers should be able to run on top of OpenWhisk. While you're creating your services, you can use the Whisk CLI, which is available for most of the developer OSs out there. You also can do a lot of development around the UI that is provided within Bluemix. This would be specific to Bluemix. You can use your existing continuous integration tools to basically build your services and then deploy them based on the Whisk CLI. You can create scripts that do that for you, and you can also create managed APIs using a gateway of some sort. In this case, we used API Connect to kind of expose those APIs as managed REST APIs. So if you look at a lot of these serverless services that are being created, they're obviously microservices, so you can see that they're really narrowly business focused, so they're supposed to do one specific thing, which is a business need. They're also stateless and short running, which means that we don't want to give them loads that are going to take a long time to run. They're usually supposed to come and go very quickly. And also they're going to be polyglot, which means that while their data communication mechanism might be very similar in terms of the formats, such as JSON, each services can be run in individual languages. Like one could be in Python because it's doing some data processing. One could be in Node.js because it's doing communication with the database. But you basically want them to be in different languages if there is a need, and you can do that on the platform. Also, the way they're consumed is either through an event trigger or through a RESTful interface. So a couple of use cases for serverless architectures. Cloud automation is one that we're seeing a lot, where you can actually control events that are happening in your cloud, like an instance coming down or an instance crossing the threshold of its scalability, being able to trigger notifications to your admin. These are all events that can be handled by a serverless platform. Also image processing and data processing, not essentially the analytical piece, but the ETL piece, where we're seeing a lot of data coming into these pipelines, being able to rapidly scale, crunch the data, and push it to end source. That's also one more use case that is being seen a lot. And obviously backends for chatbots, web applications, mobile applications, where you have to serve data to these new SPA-based applications where your UI is all on the client side and you just need data to be pumped into it. That's a really good use case for serverless, because essentially you're just pushing JSON data instead of having to push these HTML files. So in we come with our image processing pipeline that we wanted to talk about in today's video. So essentially we built a Ionic and Cordova based mobile application that takes pictures, and you can upload those pictures to an object store. In this place it is the OpenStack Swift based object store, which is available through IBM Bluemix, which is IBM Cloud Object Storage. We built a Node.js server on Bluemix, which takes the data that is coming, the image data that is coming in base64 format. It uses that data, it converts it into a image stream and pushes it into object storage. But what we were seeing was that even though storing the image into object storage is not taking a lot of time, processing it is. So what we basically wanted to do was to give a much more seamless experience to the users by delegating the processing load to a backend serverless architecture, so that it could scale when needed, as needed, and still be able to asynchronously execute this process. So essentially what you're seeing over here is the mobile application posting a image to the node server then triggering the sequence of serverless actions by publishing a message into Kafka, which is running on IBM Message Hub. So we have a topic called serverless, and the application, the node server, is actually publishing both the image name and the container name to this Kafka topic, which is triggering the OpenWhisk sequence. The OpenWhisk sequence essentially takes the name of the image and the name of the container, pulls the image from object storage, processes it, compresses it, gives it to Watson visual recognition in the format that it requires, brings back the visual recognition results, processes through it, filters those results, and updates the relevant results into the object's metadata in object storage. Once all this is done, we also wanted a notification mechanism as well. So we used Twilio to actually send a message to the user so that they can know that the image was processed. So just to look into the serverless pipeline and understand kind of what it encompasses and how much time it was taking, from the time that it took to place the message into the queue to the time that it actually sent the message to the user, the overall time was about 5.7 seconds. Now the cool thing about serverless and running it using OpenWhisk on Bluemix is that even though it did take 5.7 seconds in total, the total time that it took to start and stop the containers is about 0.9 seconds or 900 milliseconds, which means that you're only charged for the remaining piece, which is about 4.7 to 4.9 milliseconds of time. Now, as you can see, there's different memory constraints, and the pricing for this is basically gigabyte per second. So to make it really simple, if you're running 4 services which are 256 MB each, if they run for 1 second, then that's equal to 1 gigabyte per second, right? So just to make it easier, we did all the calculations for you. If we were to take an example of 50,000 images being run across 1 week, to run that on this OpenWhisk pipeline, which was running for about 5 seconds, it would cost us about 93 cents. Versus if we were to take something like a platform as a service and run a Node.js runtime on it, where all these services were running with the same memory amounts continuously rather than just when they're needed, for that 1 week period, it would cost you about $23. So it's really kind of a cost versus time versus quantity equation where you have to think about what will cost you lesser, but in this case it's about 25x of a difference in terms of the cost. And not only the cost, it also relieves you of the management headache that you have to do on top of these microservices, and also enables you to kind of reuse these services wherever you need, scale them as needed, and make sure that even if there's a problem with one of them, it does not affect the other pipelines that are running. Whereas in a runtime based scenario, you would have to enable high availability, run multiple instances, make sure that even in one instance crashes, another instance is able to handle it, and such sort of stuff. So with that being said, let's jump into the demo. So this is a quick demo of the application that we built to showcase the image processing pipeline. On the right hand side you can see our app that we built. This is an Ionic based application that takes images and input, gives it to the Watson visual recognition service, and shows us the output. So you can see if I go to an image of Superman, you can see that it got classified as Superman with a score of 97% on March 21st. So basically the use case behind this is to showcase the time, because the user has to wait 5 to 10 seconds for the image to be processed and classified. So we don't want them to have to wait synchronously, so it posts that using Message Hub to a serverless pipeline that actually processes the image and then updates the metadata with the visual recognition results. On the left hand side you can see that we have the OpenWhisk monitoring dashboard opened up. In this dashboard you can see all the OpenWhisk actions that are being triggered as part of this pipeline and how much time they're taking to actually complete and execute. So we'll quickly go ahead and we will upload a new image. Let's call this the labs demo. And let's say that we'll upload an image from the gallery. So we'll go ahead to the gallery. I already have some predefined images over here, so I'll go ahead and grab one of those. We'll take an image of the dog. We'll say done. And we'll say upload image. Yes. And you can see uploading the image takes just about a couple of milliseconds maybe. the image has been uploaded to the server. You can see that it took us about 4 to 5 seconds to update and be able to get the data saying that it was processed. If I go ahead and refresh the screen, you can see that I got the Twilio message saying that it was processed, and now the image is classified. I can go onto the image and I can see that it got classified as an animal with a score of 91%. So if we continue to look at what is there on the OpenWhisk dashboard side, you can see that we have multiple actions that got triggered. One for the image processing sequence. We then see the image process trigger also being triggered. This is the rule for the message hub feed, saying that when message hub feed gets triggered on that topic, then go ahead and kind of trigger that sequence. You can also see that it first retrieves the image, processes the image. The process image took about 2 seconds, the updation into object store about 1.2 seconds, and the Twilio call about, or the Twilio text message, about 700 milliseconds. So this is kind of a quick demo. You can see that each one is only being triggered when it needs to be triggered, so that's saving you a lot of costs, especially when there's a lot of different things that need to be done continuously. Also, it enables you to use event-driven processing so that you can delegate to web workers, which you might have done using child processes or other mechanisms in the past. It makes creating those sorts of models very, very easy using serverless services. There's a lot more videos on our YouTube channel. If you want to check them out at miraclesoft.com/thelabs. Thank you so much. Thank you for watching The Laboratory, a video series brought to you by Miracle's Innovation Labs. For more on innovation, please visit miraclesoft.com/thelabs.